Air Marshal Sandeep Singh, DG Caps, former chiefs, senior serving and veteran officers of the three services, members of the academia, chair, and all of the members of the audience here. Very good morning from DSA. We've heard the Army and the Navy and the Air Force perspectives on how we envision the progress and the adoption of space technologies into our strategic calculus and into our warfare paradigms. Let me come to the military perspectives or perspectives on military utilization of space as we see it from the Defense Space Agency. If land warfare is probably as old as from when man walked on Earth, and maritime warfare probably several thousand years old, air warfare as we speak is 111 years old. Confrontation, competition, or the utilization of space as an agency for war is perhaps of the order of 50 to 60 years if you go to the Cold War years. The speed of impact in each of these mediums has been vastly different. From the time that a particular medium became a medium for confrontation, the ability of whatever technology and tactics were used to have a major impact has been greatly different. If space warfare could have, we said, to be started in the 60s, ICBMs, basically warfare through space. Then in 1991, we saw the first Gulf War, which kind of brought to our realization that the war on the surface is going to be decided in space. That's 30 odd years. Another point that I got to reflect upon in my last 10 months as DGDSA was land and sea were used first for subsistence. We lived on land. We used land for our subsistence, for our growth, etc., etc. Then probably we got into commerce and trade, and then the confrontation, and probably a fight for resources, and then we got to the squabbling. Mankind never needed air or space for its subsistence in the same manner. And so we got down to the squabbling very fast. The first flight in 1903, which was a fabric and wood and wire and safety pins contraption, to the first bombing drop was 8 years. And that was before even the first airmail was delivered. In space, it started with the V2 in the Second World War. And the point of the observation that I have is in the aerospace domain, it is not trade or commerce or subsistence which has led the way. It is warfare which has led the way. And the spin-offs from that have thereafter flowed into the civilian domain. And today, if we find that it's industry and it's commerce that is pushing the boundaries, it is spin-offs that have come from warfare. Sorry. Okay, the broad scope of my talk here is I'm going to cover a little bit about emerging trends in space, emerging trends in terms of surface warfare, just the salient features. It will not be exhaustive, but it will be enough to make the point that I wish to make. A few observations that emerge from these and the implications of those. And then I'll go on to India and the military space domain. What is the current status in our perception? I'll speak a little bit about the DSA and then move on to what we feel are the key enablers and the key challenges that we need to overcome for us to become an effective force there. Okay, here's the launch story. 1957, Sputnik 1. The graph shows us how that particular thing went. And here we can see that a big kind of a leap as it crossed more than 100 launches per year at an average from the years between 1966-67 and all the way into the 1980s and 90s, driven by the Cold War. That's kind of obvious to us. And of course, the Vietnam War was part of the spur in the Cold War. And thereafter, 1990, breakup of the Soviet Union, the Cold War paradigm kind of collapses, and there is a reduction in the number of launches worldwide. The principal players remain the same, US and Russia. This reduction goes on roughly up to 2005-06. maybe 2010, and then starts picking up again, driven now more by industry and now by commerce. And if you see the steep spike that comes towards 2018, 2021, where now it has exceeded all of the previous, that is driven entirely by Elon Musk. Broken down into launches per decade, this is the orbital launch summary. You see 48 in that first decade of 57 to 59, rising to a peak in the 1970s of 1,231 launches in that decade, 1193, that's roughly the same. Starting to reduce in the 90 to 99 decade, the fifth decade of space, reducing to a minimum of 663 the sixth decade, and then starting the rise again. 2010 to 2019 was 957. I'll give you the statistics for 2020. Okay, so in summary, this is what that whole march is about. Since Sputnik 1, 6,120 launches. This is the successful launches. Nearly 13,000 satellites placed in orbit. Over 84,000 satellites still in space, of which it is estimated roughly 5,500 are operational. This number was 3,000 something last year. So look at the enormous rate at which satellites have been launched and being made operational. In 2020, 1,283 satellites. For the entire decade previous to that, it was 957. In the single year of 2020, 1,283. 2021, 1,800 plus. From 135 successful launches, highest till date, there were only 7 failures. 2022, 56 launches till April. Number of satellites, we don't know as of now. So congested, contested, and competitive, yes, very much. If you go by country, launches by country, and the DG touched upon that in his address, nearly 40% of the launches were by China. About a third by the US. About 1/6 by the Russians. Between these 3 countries, they cover 87% of all launches in 2021. By purpose, it might be counterintuitive, but more than 50% of the satellites in space are on communications. And that tells you where the story is. ISR domain about 27%. So between this, about 81% of the satellites. The total number of resident space objects, that RSOs, of 10 centimeters and more. Why 10 centimeters? That 4-inch is kind of a norm or a convention at which scientists have arrived to say that any object of this size or more is likely to cause catastrophic damage if it comes into contact with another object. This particular graph tells you the total number of objects in space. The pink line here is actually the number of fragments and debris. Whenever an ASAT was conducted, a direct ascent ASAT test, or whenever there was a collision, for example, the Cosmos Iridium 2009 collision, there's a steep increase in the number of fragments. If you look at the graph and the trend of the graph, you can say that it is on the upward trend. Now, this is very important for some points that we will make later. So from all of this, what are these emerging trends in space? One, there is a quantum jump in the number of spacecraft and the amount of debris that's going into space. Just to give you another statistic, as of now, there's about estimated over 9,000 metric tons of mass that has been placed in space. About 200 metric tons makes re-entry every year. The recent upswing has been driven by private entities and by commerce. It's entrepreneurship. A number of transformational technologies are being injected into space, and they're going to have a very long and large impact. LEO communication constellations. Communications was largely in the geostationary orbit domain. However, now with Elon Musk and Amazon's Kuiper and OneWeb, we are going to see thousands of satellites in the LEO belt to give us low latency, wireless internet global communications, inter-satellite links, which was touched upon by Commodore Nair as well, and autonomous satellite control, some of which is being used by the Starlink thing, where the satellites talk to each other to avoid collisions with each other. A lot of potential and a lot of impact. Very high resolution EO and SAR imagery, giving you transparency never before experienced. Add to this the numbers going up, which means more persistent surveillance. And therefore, battlefield transparency is a norm. We have to accept it, we have to live with it, and we have to work in it. Multiple GNSS options today. If it was only GPS a few years ago, and then came GLONASS, now there's Beidou, and very soon there'll be Navic. This flexibility and redundancy is available not only to the taxi driver, it's also available to the missile. Rendezvous and proximity operations, or RPOs for short. This is where you come close to another satellite, run rings around him, close observation, and so on and so forth. These are transformational technologies. They are a reality, and they're going to transform the way business was done in space. All of this means one very big thing: pervasive dependence on space services. Why pervasive? Because it is entering your and my life. It is going to affect the common man and large masses of lay populations, and therefore all of them become vulnerable and fair targets. And that I'll just come to that point in the next slide. So therefore, this impacts the common man, and that's very important. In warfare, what do we see? I'm going to leave all the big trends and just come to one core point. We're seeing a transition. We visited the super conventional or the nuclear paradigm for a few decades, returned to the conventional. And the last few decades, what we're seeing is a transition from conventional to hybrid and gray zone warfare, ambiguous warfare, where lines between friend, foe, and neutral are blurred. We don't know who the enemy is. We don't know where he is. Subconventional means multi-mode, multi-dimensional with an intrinsic deniability. Non-lethal means, but with lethal effects. Large masses of populations can be affected directly, which means your rear is no longer safe. And warfighting may not commence on the borders and not between militaries, but the weakest element will be targeted first and weakened so that the soldier is always looking over his back. Non-military targets, including the lay populations. Fair game. In space, there is an exact parallel. Dual-use technologies. It's a false dichotomy to say these are military assets and these are civilian assets. It's a myth. Except for a direct ascent weapon or some other nasty tricks department kind of technologies, everything else is dual use. And therein lies an inherent ambiguity and the difficulty in distinguishing between what is a civilian asset and what is a military asset and who may be targeted and who may not. Cyber tools are the weapons of choice. Intangible, invisible, highly effective. Ambiguity and deniability is intrinsic in the entire paradigm. And if you go back to what the trends in space, then space enables hybrid and gray zone warfare rather well. A few observations about this. Space is inherently very, very attractive to everybody. One, it's the ultimate high ground, that's been said many times. Single reason, global reach. Also speed. Niche technology. The technologies that are used to be somebody in space are not available to everybody. Very often we kind of use a very loose term to say man has reached the moon or man is able to do this. Which man? Not every man. And those who have it do not share it because they form a small and elite club. They will want to hold on to this technology because decisive asymmetry is possible through space. And it will neutralize all other conventional asymmetries that you have. And therefore, technology denial regimes are a norm. It's another thing that we have to live with. Space, therefore, is an ideal instrument for domination. What's breaking this all now? The entry of the private entities and commerce. So space warfare can take place through space, which started with the V2s, an established normal way of operating through the Cold War, and even now with ICBMs and all of that. From space and in space is currently prohibited by laws. But to what extent have people actually adhered to it? Questionable. Space-enabled surface warfare has been on for a very long time. Through ISR, through PNT, through communications, and through a variety of other things, services that are given through the agency of space, but empowering the forces on the ground. So militarization is a done thing for a long time now. Weaponization, we really don't know. Actually, we do. Okay, let me come to ASATs. Now I'm coming to a little bit of the text of the matter, leaving the context of the overall thing. These are some of the very attractive technologies and things that I talked about. Direct ascent, or DA ASAT. There's a huge amount of debris that is created in this kind of a thing. 4 tests have been conducted so far, the last one by the Russians last year. The estimated amount of the debris and the altitudes at which this was created, the American test was actually at around 700 to 800 kilometers. And the debris is going to re-enter over a period of decades through the entire Leo constellation with no control. There's a massive debris fallout. There are other lethal ways. Directed energy weapons, RPOs in which grapplers and robotics can be utilized to directly grapple with a satellite. Co-orbitals. People also talk about space mines, which can be discharged in orbit and left for somebody else to go through. There are a number of non-lethal ways, cyber being the most prominent and perhaps the easiest to employ. EMPs, dazzling, etc. have been talked about. The big conundrum when it comes to a strategic conundrum is direct asset ASATs. What is the true utility? The jury is still out on this. We really don't know. If we start knocking out, as was covered, we will soon have an incredible amount of debris with no control, unpredictable, sudden impact on everybody, including the neutrals. However, it has a high deterrence value. Once you have demonstrated the capability, now it leaves everybody guessing. So it's a little like the nuclear paradigm. Perhaps a weapon not to be used, but to be demonstrated. High deterrence. Then there is a launch on demand. That's another very attractive thing. I've had some quality time to spend on some of these things. Again, it's a capability that we must have. However, there are a number of considerations. One, what kind of rocket? Do you go for a PSLV class? Do you go for a GSLV class? So what is on standby? Payload. What payload are you attempting to replace? So what is the purpose of this entire thing? We need to make choices. Orbit considerations. In what kind of an orbit does it have to be injected? What are you trying to replace or what are you trying to augment? All these would have to be prior decisions. So the purpose and the readiness considerations also have a certain amount of complications in it, technological, budgetary. For example, if a satellite never gets launched for 5 years. So it's not as straightforward as it may appear. RPO and robotics, again, it's an inherently dual-use technology, for example, for debris clearance. And the entire range of activities that RPO is capable of doing till ASAT, in which case you can directly go grapple with a particular satellite, topple it, deorbit it, damage it. With this technology, docking is possible. So anybody who's able to dock, for example, the shuttle with the space station and so on and so forth, has RPO capability mastered. In future, it may be possible to refuel satellites and extend their lives. Close observation may be possible. But for all of this, we require very, very high level SSA and SDA, that's space domain awareness, without which this kind of a thing would not be possible. Earth observation technology itself, today we have very high resolution EO down to 10 centimeters level in the world, not necessarily with us. Hyperspectral, infrared, so multi-bands, multiple capabilities. SAR, ELINT, and fused pictures. What does this do? If there is clouding and you cannot have an EO shot of a particular area, then you have a SAR shot. When you have the capability of taking both of the same thing, you fuse the pictures and it gives you much more information. In addition to that, if you add the ELINT footprint to it, now it is possible to, for example, go off a ELINT signature and then come on to it. So edge computing, which means computing in the satellite itself, a first level of processing in the satellite, certain decisions being made, AI ML-based processing on the ground. Add to that persistent surveillance by increasing the number of satellites or through collaborative means with other nations. Tip and queue formations. These are some of the technologies which are very rapidly happening and which we are also weaving in some of our proposals and projections for the future. Tip and queue is basically where one satellite is flying in formation with another one. The first one picks up, let us say, an ELINT signature or a SAR signature, and to explore that further, it cues the next satellite to take a picture of it. So overall battlefield transparency is with us. Okay, let me come to the to India and, sorry, have I missed out a slide? Okay. There's something that's happening recently, which is a number of space agencies have suddenly sprouted or have been reorganized. So what exactly is it that's happening that's forcing nations to take a relook at how they are organized for the military space domain? So what's the thought? Indian DSA, we came up with in June 19, the French Defense Space Command, September 19, just a few months after. US Space Force was brought into being, although they've had a space command for a long time, and it has morphed many times over, in December 19. The Australian Space Command, Jan 22, just a few months ago. So there is overall, all over the world, with the main players, focus on streamlining their military space activities. Another big fellow which is entering, and I'll leave the third session to deal with this, is lawfare, which is warfare through legal frameworks. There is a revisit now of space laws. There is something called the Artemis Accords, which has now been proposed and on which there is a lot of thought and debate going on in the UN. This is basically what had happened was in 1967, the Outer Space Treaty and the various principles and treaties that have come after that. They all, at one point, the Outer Space Treaty says that at a time when technology is matured enough for mankind to start doing space mining, we need to get back together and frame certain laws and protocols by which we will govern and control these activities so that we don't get into a fight in space. That time has come. And hence the Artemis Accord, and that is all about going to the moon and moon mining and so on and so forth. However, there are apprehensions on whether these are going to be fair or are they just other denial regimes in disguise. India as a spacefaring country, we're ranked in the top 6. We are in the cryogenic club, exclusive club of 6 countries only. We have the PSLV and JSLV rockets. The SSLV, the small satellite launch vehicle, is about to be tested. Reusable launch vehicles are about to be tested. And we cater to the international market as well. We have had the Mars and lunar probes, cheap and first shot successes, which is difficult. With the IRS, that is the remote sensing satellite series, and the INSAT series, we've had 70 odd active satellites currently, and a total which exceeds 100. Some of them are no longer functional. So we are a player. However, there exists a very clear capability gap when it comes to our adversaries. We started late, as was touched upon earlier. We largely started after Kargil. And thereafter, our progress has been kind of slow. Now, if you go back to the Chinese, who were actually much behind us at that point in the 80s, they took their lessons from the 1991 war very seriously. And in 3 decades, they are now the second largest player, and they're actually outrunning the US. Roughly, statistically, 1 launch every 3 days. However, I think the alarm bells have been sounded, and we are taking very decisive corrective steps. And I'll just touch upon that. There is a huge transition underway, there is no doubt about it. With the NSIL, with InSpace, with ISPA, and that's coming in section 2, the space sector is opening up to private industry. And the import of this and the long-term impact of this cannot even be estimated now. If we do it right, we have enormous potential waiting to be unleashed. ESA was brought into being in 2019 as a nodal agency for space requirements of services. Along with that was the Department of Special Projects, or DRDO, as the tech partner and oversight through 2 apex bodies. Sir, sir.
We're running out of time here.
Yes, sir. So the broad charter for us is to empower the 3 services: command and control of defense space units and protection of space assets. And our growth map basically has an expansion of the space and ground assets and the earth stations, bring in good ground exploitation systems, establish ground units for operational tasks as we go along, and eventually scale up. Focus areas for us are acquisition of SSA, expansion and strengthening of the NAVIC footprint, comprehensive ISR through EO, IRSAR, and ELINT, high-capacity secure communications, credible deterrence and counter-space capabilities, work on the military space doctrine and NSSP, which is already underway, space aspects in wargaming and exercises to be included, and integration of the joint services inductions, interoperability, and joint strategies manning. Last slide. Adequate funding, timely approvals is required for us to actually be in the race in space. If those models are not developed, we will be back to the same. Key technologies are necessary, which we do not have in the country, and we are dependent abroad. These dependencies are vulnerabilities, and somebody can choke us. We require a fused civil-military HR model. Military space cannot be sustained on the basis of military manpower alone. Most importantly, as a country, we need the ability to absorb technology through restructuring and reorganization, new arrangements, reorientation of doctrine, strategy, and tactics in the military domain, and the ability to train and retrain with agility. Cooperative structures for civil military space, that is ISRO, us, DRDO, private players. With that, I've come to the end of my talk here, and we will take on the rest in the question and answer session. Thank you very much, Jai Hind, and thank you for the invite, sir.
Okay, thank you, Khot.